Okay, so let's go through question 6. We have this C1, right, center, 3, -1, diameter AB, where A is the point 6, 3. Find the radius of the C1 and the coordinate B. Okay, so for the radius wise, it's simple. You simply just use the length formula, right? So square root x1 minus x2, bracket square, plus y1 minus y2, bracket square. So if you calculate correctly, so this will be 9 plus 16. So this will be square root 25, which will give you 5. So this 5 units. Okay, next thing, the difference will be your finding of coordinate B. So if you draw a right angle triangle, so I want to find what is the horizontal length of this right angle triangle. You simply just use 3 all the way to 6, right? So 3 all the way to 6 is about 3 units. What about the vertical height? So from -1 all the way to 3. So this will be 4 units. Yeah, so this one is the Pythagorean triplets. Next, I simply just draw another right angle triangle, and these two right angle triangles, they are the same. Okay, so this will be 5, this will be 3, and this will be 4. Okay, by looking at this, you look at these 3, right? You go back by 3 units. So your coordinate B has a x coordinate of 3 minus 3 is 0. Okay, what about the y coordinate? The y coordinate, -1, you go down by 4 units, which will give you -5. So that is how you do your find your coordinate B. Okay, for part 2, that's the simple one. So part 2, you want to find the equation of the circle, right? You simply just put x minus 3 square plus y minus -1, right? So it's y plus 1 square. So it's equal to 25. 5 square, so it's 25. So that's for part 2. Okay, for part 3, show that the equation of the tangent to the circle at A, right, is given as such. Okay, so let me just redraw the new circle. Okay, so this is the same circle, right? So of course the center of circle is 3, -1. Then the point A, which is here, right, will be 6, 3. So you just need to know for this radius, right, and the tangent, they are 90 degrees to each other. So what you need to do is actually to find the gradient of this radius first. So this radius, y1 minus y2, right? So 3 minus -1 is 4. X1 minus x2, 6 minus 3 is 3. So the gradient of the radius is 4/3. For the gradient of this tangent is roughly flip, then you change sign. Then after that you can find already. So y equal to -3/4 x plus c. So you just sub in 3 and 6. 3, 6. So this will be 3 equal to -18/4 plus c. So c is equal to 3 plus 18/4. So it's about 7.5. So y is equal to -3/4 x plus 7.5. So you just need to times 4 throughout. So times 4 and times 4 throughout. So this will give you 4y equal to -3x plus 30. Move everything to the left hand side, you show already. So it's plus 3x minus 30 equal to 0. Okay, so let's move on to the part 4. Okay, part 4, C2 is the reflection of C1 along the y-axis. Find the equation of the center C2. Okay, so for this one, same thing. I draw the y-axis first. So this is the mirror now. Of course, draw the x-axis. Okay, so the C1 has the center of circle 3, -1. So 3, -1 is roughly right here. So this is 3, -1. So this is the center C1. Okay, if your mirror is right here, so this is your mirror now. So your image of the center of the C2, right, will be right here. So it's around here. And if you look at this carefully, right, you'll realize that they actually have the same y coordinate, which is -1. They have different x coordinate. So how do I determine the x coordinate? So always remember, object distance equal to image distance. So from here to here is 3 units. So of course from here to here, right, must also be 3 units. So from 0, right, go back by 3 units, you will get -3. So that is how we determine the center of the circle, C2. Okay, what about the radius? Because it's just a reflection. So the radius must be equal to 5. So it's radius, okay, so the equation of circle, right, is x minus negative 3, right? So it's plus 3 bracket square plus y, okay, y plus 1 bracket square will give you 5 square, 25. Okay, so the last part, find the coordinate of the point of intersection of the two circles. So the object and the image, right? So let me just draw the thing first. So I draw this, right? Roughly lah. Okay, so this is the object. Then this one is the image. Okay, so the intersection is roughly right here. So it's these 2 points. Okay, so first, how do I know what is the intersection? Very simple. They will intersect at the circumference, the so-called the circumference of the circle. So for this, right, since we know that the radius is 5, so I just need to draw a radius 5. So this is 5, right? So of course, if you recognize one more thing, this is a right angle triangle. So this is 3 units, right? So the horizontal length of this right angle triangle is 3 units. What about the vertical length? So vertical length, I'm talking about this thing from here, right, all the way to here. So this is 3 units. This will be 4 units because it's right angle triangle, right? You use Pythagoras theorem, so 3, 4, 5. Okay, next I want to determine this point. So this point, you simply just go back. Okay, you go back. Okay, so let's determine the x coordinate first. So for the x coordinate, -3, you go towards the right hand side by 3 units, right? So you realize that it's actually 0. Okay, what about the y coordinate? So the y coordinate, so it's 4 units here. So -1, you go up by 4 units, which will give you 3. So the intersection is actually 0, 3. That's the first intersection right here. Okay, what about the second intersection? Okay, second intersection will be right here, right? So same idea. I draw the radius. Let me just erase a few things first. Okay, never mind, just draw. So this is, so this will be 5 units, right? So same idea. This thing will be 3 units, and this thing will be 4 units. So of course, the x coordinate of the intersection, -3, you go towards the right hand side by 3 units, is just 0. Okay, what about the y coordinate? So the y coordinate, -1, you go down by 4 units, you will get -5. So that is how you solve the part